Okay, so in this question I'm going to go over a parametric equation problem from a mathematics A-level paper in 2021. It was the pure paper, it was on to, more than halfway through. Questions in A-level in general and parametric equations in particular will try and test different aspects of kind of cross-topic work. Some of them are trigonometric, so probably using trig identities, trig differentiation, and such things, and integration occasionally as well. Some of them are kind of more algebraic, so it's testing our algebra skills a bit more. And some of them test our exponential logs, as this one. So it's testing that alongside that knowledge of parametric equations, which is often the case in A-level in general, but this topic in particular. So they will try and do things. So the first part is a little bit of interpretation of a curve, and it says so it never crosses the x-axis. It would cross the x-axis if or when if y equals 0, but y is equal to 2e to the minus 3 over 2 t is greater than 0, because it's an exponential function. It's going to do that as t increases for all t, say, because it's never 0. You could try and solve it and then say you can't take the ln of 0. I think they'll probably accept that. I haven't looked in, but anyway, we need to explain that this has got that this equation. You could, I suppose, also say 2e to the minus 3t equals 0. I'll write it down here, put in brackets. Has no solutions. But don't start saying maths error or anything that the calculator does, because that will go down badly and probably forfeit any marks. Okay, so part B. Part B is again a bit of interpretation. It intersects the y-axis. When x equals 0. So that gives me e to the 2t minus 4e to the t plus 3 equals 0. Now, some of us, myself included, would probably recognise that as what's sometimes called a disguised quadratic, and just notice there's only 2 marks for it, and I think that's what they imagine that we're going to do, and do that by factorising it. But I do appreciate that some, that's a bit too much in one go, so some people don't see that. But we need to kind of recognise this is a disguised quadratic. So I will do that, or if you would prefer, we could write it as a kind of just so we see the quadratic like this. And then let e to the t be equal to some value. I wouldn't let it x or y because they're used in the equation. So maybe w or whatever wa, or it doesn't really matter. So it's w squared minus 4w plus 3 equals 0. So w minus 1, or let's do it in the same order as the one above, w minus 3 and w minus 1 equals 0. So we have w equals 3 and w equals 1, and then we get to the same place. We get to e to the t equals to 3 and e to the t equals to 1. E to t equals 3, obviously that undoing that gives us t equals to ln 3. E to the t equals 1, that gives us t equals 0. Now the question hasn't asked to find the actual coordinate where it crosses the y-axis. It's going to cross, so these basically what's happening. I'm not sure what the curve looks like, but it's crossing twice, maybe, and it's got the 2, but it's not asked for the coordinates, so we can just leave it there. Right, okay, part C. So again, it's not too much to to deal with here. We can just say we've got x is equal to e to the 2t minus 4 e to the t plus 3. So differentiating that, we get dx by dt. This 2 obviously needs to be multiplied, so that's 2e to the 2t. And this just comes to itself, and the 3 disappears. And we can do the same with the y. Y equals 2e to the minus 3t. That gives us dy by dt. We need to times by the minus 3. So that gives us minus 6e to the minus 3t. So kind of using the chain rule, or just think of it one divided by the other. Dy by dx is a quotient of these two here, of these two things. That and that, with obviously the y bit on the top. So dy by dx is equal to dy by dt over dx by dt. And that is going to be equal to 2e to the minus 6e to the, this bit here, minus 3t over dx by dt, which is this bit here. That's 2e to the 2t minus 4e to the t. Now that can be simplified, and that's what they're doing. They're making it so that. So I always concerned with this type of question that we make sure that we have made it absolutely clear how we get to that. So we wouldn't be able to just, even if you can do it in your head, I mean, it is a stretch, but it is conceivable that someone could do that, could see that these are the same thing. But it's no good to convince yourself of it. We need to basically convince others if we're reading it and the examiner, we know what we're doing. Well, generally speaking, we don't want negative exponentials in a fraction. Well, it's not always true, but it's certainly not positive and negatives on top and bottom. So we can take that e to the minus 3t on to the bottom. So that's minus 6 2e to the 2t minus 4e to the t, all times by e to the 3t. Okay, because that negative index on the top becomes a positive on the bottom. Or if you prefer, you can think of it as timesing by e to the 3t on top and bottom to get rid of the negative indice, because then you're going to get the e to the 0, which is 1 on the top, and then you're going to get the thing on the bottom that we want. So whichever way you want to think of it, take the e to 3t to the bottom. So that's probably something the examiner would like to see, and then we can multiply that out. Okay, that's all. We're almost there now, because it's looking quite similar to this, but obviously it's divided by minus 2 on top and bottom, or we're taking the negatives, divide by minus 2, I suppose, on top and bottom, or negative minus 2. So changing the sign of everything and dividing by 2, basically. So that gives us 6. And then that's minus e to the 5t, and then dividing that, changing the sign of that, that's plus 2e to the 4t. I suppose we better write it exactly as they've written it, just to be, or I've wrote 6, but obviously I meant 3. 6 divided by 2 is equal to 3. So we've got minus 2, 3. So that's, 3 2e to the 4t minus e to the 5t as required. Okay, and that is it for that question. And so it's 4 marks. So I don't think it's too bad. A little bit of algebra involved, but it's testing a few things. But I think we're kind of going through the motions mostly here. They have tested out, they have kind of stretched us a little bit here, because it says where it's hence find the coordinates where it's parallel to the y-axis, so basically where the path, the tangent is vertical. So that might flummox a few people. Well, the thing is, I don't want to really say dy by dx is infinite, or dx by dy is naught. That's another way of looking at it. Or dy by dx is equal to infinite or undefined. So if we have, if the path is path parallel to the y-axis, basically implies dy by dx is undefined, infinite if you like, or division by 0. So it's all about equating this bit to equal to 0. So that just basically means that 2e to the 4t minus e to the 5t equals 0. Okay, so then that gives us so then that, if I can solve that. Incidentally, what I see a lot of students do here, and it's actually, you would be fine in this question, you'd get away with it, is do that and then divide. And then that would give us e to the t equals 2. And then you get it from that, get the value of t from that. Which is okay here, because it hasn't asked for detailed reasoning, and that would work, and it would be fine. I do want to pretend almost, or just go through, do the conventional thing. If it did ask for detailed reasoning, we need to kind of justify ourselves a little bit more, because that e to the 4t is kind of cancelling a little bit, and skipping steps a little bit. So if we factorize this, you'll see hopefully you'll see what I mean. If I factorize that, take e to the 4t out as a factor, I've got 2 bits. Now, e to the 4t not equal to 0 or no solutions. Again, don't say maths error. I say it's not required here because it hasn't asked to explain in detail what you're doing, but it could do elsewhere. So I'm going to do it as though it did. So then we've got 2 is equal to e to the t. So that gives us t is equal to ln 2. So once we've got a value of t, we can just put those values back into x and y to get our values for x and y. So let's do that. So we got x is equal to e to the 2 ln 2 minus 4 ln 2 e to the ln 2 plus 3. You can use a calculator here because it hasn't asked for detailed reasoning or anything. I just overwhelmingly have the urge to not use a calculator, so please, you can ignore this bit for this part of the question, or minus this bit is 4, so e ln 4 is 4, and e natural log ln 2 is 2, so that's 4 times 2 plus 3. That comes to minus 1. But say you can use a calculator here. And then y equals to 2e to the minus 3t, so minus 3 ln 2. Again, the calculator will give you the answer, which is a quarter. If we want to justify that without the calculator, that's 2e to the ln 2 to the minus 3. Note that 2 to the minus 3 is equal to 1 over 2 cubed, which is equal to 1 over 8. So that's going to be equal to 2 times 1/8, which is a quarter. But as I say, the calculator will do it for you. So I'm not suggesting in the exam you would do that in this situation when the calculator does it. So then we have got our coordinates. So it's parallel to y-axis when the x-coordinate is -1 and the y-coordinate is 1/4. So a little bit involved there. Some of you may have not have kind of appreciated it's the denominator 0 if you ever have a tangent which is vertical. So if nothing else, if nothing else, hopefully that's been useful to you, and I hope the video in general has been useful to you. Okay, that's it. Bye.